And thank you everybody for the organizer for inviting me to this very interesting conference. Let's start with the meaning of food, or actually the evolution of the meaning of food through the last centuries. Now, from the 50s, consumers were perceiving food as a way to get calories, to get nutrients. But then you see, basically, by moving towards the 80s, the 90s, consumers were much more focusing on something more than that. So looking for foods that basically were providing health, prevent from non-communicable disease. And now we end nowadays where food is perceived as a way to treat medical conditions. So you see, basically, there's been a huge jump in terms of the meaning of that food has for consumers. So, but besides the fact that basically the food let's say, concepts being evolved dramatically, at the same time, we saw that this evolution got some cost, and in particular, in the environmental, let's say, in particular, environmental cost associated with food production. As you see here, basically, if we are keeping using our food in the way we're used to for the last, let's say, 50 years, in 2050, we need 3 planets of natural resources to make sure that basically we can feed everybody. And for this reason, also, the European Union actually is acting very strongly in this area, And in particular, they launched last year the new Green Deal, and basically that aim to change the way we are producing, we are processing, we are consuming, and we are disposing our food. And this is very, very, very important. If you want to be a leader in the food transition that basically we are facing nowadays. Well, I'm saying this because if you see some of the vital indicators, you see that basically we are in the way we are managing our planet. We see that our CO2 concentration is rising, temperatures now are climbing, and one field is suffering. But in the meantime, you see that basically the population is growing, and even as more people than ever before are overweight and obese. So definitely there is something wrong, something that needs to be changed, and something needs to be changed now. So. And this actually is particularly evident when we see the different food system limitation that basically we are facing nowadays. As you see here, pointer, yes, here we see basically one out of 3 people suffer from malnutrition. We have a third of our food is basically wasted, got in the bin. And our food is also too rich in fat, sugar, salt, and meat. So we need to restructure the way we are receiving food. And also at the same time, we are producing this food at the expense of the natural resources. So definitely we need to also make sure that the different actors that play their role in the food system will start speaking the same language. So we need to remove this silo thinking behavior among different players in the food system, starting from government, producer, consumers, and business people. So Smart Protein was actually aiming to start producing differently and eat differently in a way that basically the food we're gonna be produced will be healthier, and also we are aiming to make sure that we have a fair income distribution and not among the actors in the food system. This is something that's very important, and also to in a way give acknowledge the key role, in particular the primary producer have in preserve and protect our planet. Definitely, of course, as you see here, in 2050, there's a question mark in what we are going to eat. So, and that's why we are now, the EU Commission is actually investing a lot of effort financially in basically developing alternative solutions that basically will help us to move towards a fair and just transition. And of course, in doing this, we have to answer 3 different questions. How to ensure how to ensure nutrition, healthy and sustainable food for everybody, how to set up a food circularity, and how to restore diversity. Well, this is the main answer, the main question that basically Smart Proteins try to answer with an impressive consortium from 23 different partners. You see mainly from Europe, also from States and also and Israel and Switzerland. So, and a very good team. We are making sure that basically we are taking into consideration any step that basically need to taken to make sure that basically we can deliver and reach a safe and just operational space, because that's what is more important. Of course, beside the number of parties that basically involved in this project, is mainly focused on plant. And there is a reason why. Because is one of the few protein sources that basically are intimately connected with the environment. The idea here is to produce more better with less. So we are taking consideration also the fact that basically to produce a nutritious food, we need also to have or improve the soil fertility in order to make sure that basically this could happen. So we are taking a holistic approach, in particular, internally from farm to fork. Different sources will be taken into consideration, but the byproducts from pasta, bakery, and brewery side streams will be used for growing eastern mushrooms, and also chickpea, lentil, quinoa, and fava bean will be the protein source that we will be taking into consideration. We're starting from selecting varieties, developing new processing, extraction, and fractionation, and then on food development. Of course, the main goal is to deliver a wide range of food products from fish and seafood, pastry, cheese, meat, infant food, and milk alternatives. Of course, the main target, the main challenge that we are facing at the moment is to make sure that basically the process and the product that we're going to develop will be natural, will be tasty, will have an appealing texture, appearance, but also be affordable. So this is another aspect that basically most of the time companies that are developing alternative food, alternative plant-based products, they're not taking consideration. In order to make sure that the mass market will embrace or will face the opportunity to enjoy, embrace this protein transition, we need to make sure that the product we develop will also affordable for them. So definitely, as I mentioned before, Smart Protein is focusing on three main routes to and make sure that this transition will happen. So starting from agricultural, developing also primary production using regenerative agriculture. So basically regenerating our environment, our soil, in order to make sure that basically the environment and the planet will always be able to feed us. At the same time, developing new sustainable food production and food processing, and also endorsing circularity. This is another aspect that basically we're going to address significantly. So in a few words, we try to build back better after the pandemic. So as you saw from the previous speakers, also from Armando, from the Good Food Institute, alternative proteins is on the way now to, let's say, rise in the next 10 years. And definitely, the reason why, in particular, plant protein is not seen a brilliant future is because they are still perceived by consumers as healthier and also and much more sustainable than animal food products. Of course, there are several challenges that need to be taken into consideration that we're going to address this in a few minutes. Of course, when we are thinking about what we should do and what should be the trends and how we're going to shape the plant-based foods, taste and texture are the primary aspect that we should take into consideration. People say that basically, yes, I want to shift to more plant diet, more plant, diet because I care environment. But then the ultimate choice will be only, approaching foods that basically are, let's say, resemble or provoking pleasure when they are consumed. It has to be convenient, so easy to process, and also definitely able to improve the health status of the consumers, but also supporting them in the weight management. Protein content. Protein content is important, but definitely something even more important is the quality of the protein. You know, because this is one of the weak points, and most of the time, you know, food products basically containing high plant proteins has been accused not to. And of course, environmental concern is also something very important. As I mentioned before, regenerative agriculture, this is the most important to make sure that we are reshaping the food environment in which consumers are purchasing, processing, and disposing food. Reconnect the consumers with the primary production, with the process, to make sure that basically they are get familiar, they understand the meaning and the power of the daily choice when they basically go to the grocery. Of course, we are working on plant protein since 2015, when the EU Commission was actually funding a project called Protein to Food, where I was actually partner and scientific advisor. And here I want to just give you a short, share with you a short video where basically summarize the main outcomes of the protein to food. I don't hear the sound, so that's video. Can someone else tell me if the sound is there?
We can't hear the sound. Yeah.
Okay, so let's move to the next slide. Stop it, video. But definitely, there is a Protein to Food website where basically you will have a chance to see all the outcomes that basically have been published, has been achieved, all the scientific publication has been released, and they are basically open access. So everybody will have access to the outcomes that's been delivered. Here, I want to just give you a short overview about the main achievement we got on Protein to Food. And as I mentioned before, we were now targeting different plant protein, and one of them was actually lentil. And here you can see, and we were using lentil for basically developing infant food formula, plant-based infant food formula. As you see here, when we're talking about plant protein, definitely there is so many advantages, but also there are some challenges that basically need to be faced in order to make sure that basically the full potential of this protein will be embraced. First of all, the food map content. This is something very important that potentially most of the time companies are underestimating. The food map actually are considered main responsible for IBS. In Europe, around 20% of people suffering from different degree of IBS. So there are fermentable oligosaccharide, monosaccharides, and polyols. And in particular, legumes are quite rich in these compounds. So their extraction process and the fractionation actually really help to reduce significantly the amount of these compounds that basically could potentially challenge our consumers. At the same time, also here in particular, we were comparing two different extraction processes. And you see basically from isoelectric precipitation and ultrafiltration. So two different extraction processes from lentils. And you see basically that both processes were helping us to significantly reduce the food map content, and also the trypsin inhibitors, so the anti-nutrients that basically sometimes are associated with the legumes, and also definitely improving the lentil protein digestibility. So you see, by processing the raw material, we can actually deliver ingredients that basically will match the nutritional quality basically we are looking for. Here, here in the case of the fava-bean protein, we were basically investigating again here 2 different extraction methods, and also we evaluate the in vitro protein digestibility. As you can see also here that as we see for the lentil proteins, the extraction process was significantly able to reduce the food map contents in these ingredients, so basically reducing the risk to create IBS symptoms in our consumers, significantly also reduce the anti-nutrients, in particular vicin and combicin, now quite non-allergenic in the fava-bean, and also the in vitro protein digestibility was significantly improved as well. So as you see here, there is a plus and a negative aspects in processing legumes protein. One side, you are reducing some of the anti-nutrients or some of the compounds that basically could have a negative effect on human health. At the other side, you potentially you are depriving the ingredients of some of the micronutrients that basically could actually be relevant. And I'm speaking about minerals, for example, that are actually very, very, very relevant. Okay. As I mentioned before, in this work, we were actually using lentil protein for developing an infant food formula. And as you see, also here, the results demonstrate that the particle size distribution was very, very uniform and fine compared to the soy-based formula and the rice-based formula. And also this actually allow to show a better technological performance when the powder will be rehydrated. At the same time, also the protein digestibility was actually the in vitro protein was actually important and relevant. Of course, much lower than the rice-based formula, but that's because in that case we were using protein hydrolysate to develop the infant formula. So again here, the model lentil formula has a similar digestibility and physical stability value of a commercial soy-based formula. So it could be considered an alternative solution. Of course, this was a kind of a starting point of an investigation. Now on the smart protein and follow-up projects, basically we are moving to an industrialization, so an validation, demonstration of this technology and these ingredients at industrial scales involving nutrition. And of course, again here, Armando before was actually talking about developing new food categories, and he was mentioning bread and pasta. In this case, we were actually using different protein from buckwheat, fava bean, and looking for developing, high protein ivory pasta. And we see here, when we're developing these particular products, you also have technological challenges, because in the pasta you have the al dente effect, so the strength of the pasta need to be kept even after, not during the cooking, at the same and also and also the consistency of the pasta itself. And you see here basically that when we did an in vitro digestibility and in vivo nitrogen balance, the protein efficiency rate was actually improved when a combination of different protein sources would be used and by replace a portion of wheat flour. As well here you can see the trypsin, the vicin, and combicin was actually significantly reduced, in particular after the pasta was cooked. So also the process, the technological process, we actually have huge influence in modulating these compounds. Here also, again, we were using the same approach for the bread production, and also again we saw that a different combination of protein was actually allowed to develop a better amino acids profile in their products. Also, the protein digestibility was actually improved, and also the anti-nutrients compound was actually significantly reduced as well. So there is a way to now successfully incorporate these protein ingredients in different food categories. And I mentioned here a few of them, but there is a wide range of potential. Of course, the last but not the least, we were also working on the plant-based milk substitute. And definitely the main force that guide consumers towards this new type of products is basically digestive wellness. As Claire was mentioned before, lactose intolerance or allergies seems rising, and that's also the reason why consumers are much more focused in alternative solutions. And the reason why you see basically the increase in the market trends now for the next couple of years. When we decide to focus and work on this, we just have a look on what was on the market. And then we just have a quick look on the composition to see basically that what we are having is healthy. I'm not saying healthier than milk, but healthy. And that's what we saw. Basically, we compared the composition, the visual appearance, the physiochemical properties, and glycemic properties. But we saw that basically half of the sample had very low protein content. So what they were doing is they were selling water and sugar. And only soy was actually the milk, the plant-based milk, basically could have a considerably high amount of protein. And also you see basically here the separation rate was basically show a poor suspension stability without stabilizer. Only soy-based products show good results. The carbohydrates, consider low carbohydrate content, rise due to the starch. The starch basically showed very high glucose content. Also, you see basically in vitro glycemic index. You see the coconut and the rice milk was basically very, very high. So when you approach this product, you think it's much healthier, or this could be an health solution for your problem. But then when you look to this data, you see basically you have to be careful when you are choosing what you're purchasing. So definitely products with high glycemic index, low protein content, low suspension stability, low mineral and vitamin content, especially when compared to milk. So definitely there are room for improvement. Now using different technology, different ingredient, processing, enzyme fermentation. Here are just the last slides. I want to show you basically what we did. And we were using here, in this case, we were using completely different approach. We didn't functionalize, we didn't purify protein. We used the whole flour, in particular starting from quinoa, and using different enzymatic process, amylase and protease. We were able to improve protein solubility and the protein content in this water extract, also to convert the glucose in fructose by glucosamine, and then by fermentation we were converting fructose in mannitol. So basically reducing the glucose content, but also the glycemic index. So there is a way to improve basically the products technologically in terms of texture, flavor, but also a nutritional aspect. So definitely there are several hurdles still not that busy need to be overcome before a great proportion of the population adopt this type of food products. Definitely consumer hardness. We need to make sure that basically consumers are understand and perceive the relevance on this protein transition. Nowadays, when I'm going to purchase a steak, I'm not paying the real value, the real cost of the steak, because I'm not paying, the consumers are not taking into consideration the environmental cost associated with the purchase of the steak. And this is something that basically need to be taken into consideration. Technological hardness. Definitely here we have the tools to functionalize the proteins in a way that basically will fulfill our expectation in terms of texture, color, flavor, and aroma. Definitely, as I mentioned before, commercialization hurdles. We need to make sure that the ingredients we are delivering are affordable and have a relatively low cost. And this is very important because otherwise, we will always have the lifestyle consumers embracing our products, but never the mass market. And the mass market, I think, we need to make sure that the change will happen.
Emanuele, I'm sorry, we are out of time.
Okay. The last, nutrition.
Thank you.
Definitely, we understand basically how the impact of differences in protein digestion, digestibility, absorption, satiety, amino acid profile, and endogenicity. Thank you so much for your time.